Hello friends, welcome to Apdemy's live class. Today, whole day from 9:30 to 5:30 Indian time, we will be conducting several classes on physics, maths, chemistry. So we are a bit late, few minutes. So we will be beginning with some physics problems. And we have picked up these problems from previous year's IIT question papers. So I think if we discuss how to tackle such problems, it will be beneficial for you. So initially, we have chosen problems from different chapters. So first one is from gravitation. Okay. So let us consider this particular problem. I think it is visible to you properly. See what is the problem. Two satellites, S1 and S2, revolve around a planet in planar orbits in the same sense. In the same sense means this is the planet and around which two satellites are orbiting. We are assuming it is circular orbit. Okay, and they are moving in the same sense means if this is moving in anti-clockwise direction, satellite 1 is also moving in anti-clockwise direction. So there is a planet P, there is one satellite S1, there is another satellite S2. Both are moving around the planet P in anti-clockwise direction. So when you have, there is a phrase like same sense in the problem, you must understand that they are moving in the same direction. Means if they are clockwise, then both are in clockwise direction. If they are anti-clockwise, then both are in anti-clockwise direction. And if it is said that they are moving in opposite sense, then one is orbiting in clockwise and another is in anti-clockwise. And periods of revolution are 1 hour and 8 hours respectively. That means for planet 1, if I take period of revolution as Q1, then Q1 is 1 hour. Okay? And T2 is 8 hours. Okay? Period of revolution means from starting from a point, fixed point, it takes 8 hours to come back to that point. And starting from a fixed point, it takes 8 hours to come back to that point. So Q1 is 1 hour, T2 is 8 hours. It is said like that. The radius of the orbits of S1, so radius of orbit of S1 is 10 to the power 4 kilometer. So radius of S1 satellite is 10 to the power 4 kilometer. R2 not known so far. Find the speed of S2 relative to S1. The angular speed of S2 as actually observed by an astronaut in S1. Okay, so this is the problem. So just let us discuss about the gravitational mechanics of satellites around a planet. So, and you see why actually it may not be circular orbit, it may be elliptic orbit, but this problem talks about radius of the orbit, that means it is a circular orbit. So it is for simplification, we are assuming the problem is saying that the orbit is circular in an indirect manner. Okay, now what is the mechanics of this particular motion? Let MP be the mass of the planet and let M1 is the mass of satellite 1 and M2 is the mass of satellite. Is it clear? We are assuming like this. Now since S1 is orbiting in a circular path, when there is a circular motion, it is a uniform circular motion. That means speed of motion is constant. Okay, so I assume speed of S1 is V1 and speed of S2 is V2. Okay, so whenever there is a circular motion, the velocity vector acts tangentially, and therefore, when it is in this position, when the satellite is in this position, velocity vector is in this direction. When it is in this position, velocity vector is in this position. When the satellite is in this position, the velocity vector is in this direction. But that means velocity vector is continuously changing, and it is tangential to the circular orbit. But the magnitude of the velocity vector is always same. And how the v is determined? If this is the radius of the circular orbit, then I can always write gravitational force GMP in1 by R1 square. What is this? It is the gravitational force of the planet on the satellite, and this force is supplying the centripetal force for circular orbit, for executing the circular motion, and its value is actually how much? mq1 square by r1 square. So this is the basic equation of circular motion, and in this case there is a planet whose mass is mp, and m1 is the mass of the satellite one. So gmp m1 by r1 square is mv1 square by r1 square. So from this, what I can do, this is m1 v1 square by r1 square. So if I cancel m1, this is not r1 square, this is r1, because centripetal force is mv square by r. That we have learned from basic rotational motion. So gmp m1 by r1 square equal to mv1 square by r1. Okay. So what is v1? V1 is actually what? V1 is the linear speed of the motion, and which is nothing but r omega. R1 omega 1. R1 is the radius of the circular orbit, and omega 1 is the angular velocity of rotation. And you know omega 1 in case of circular motion, it is 2 pi by t1. And t1 is the period of motion. So all these things, if I connect properly, then 2 pi r1 by t1. All right. So if I substitute this v1 in this equation, then what happens? gmp by r1, because one r1 cancel, I get v1 square. v1 square is 2 pi r1 by u1 whole square. Is it okay? So it is what? 4 pi square r1 square by u1 square. Up to this, is it okay? So I can write gmp from this expression. gmp t1 square is equal to 4 pi square r1 cube. So t1 square is equal to 4 pi square by gmp r1 cube. And this is for the orbit 1. Period of the orbit t1 is connected to radius of the orbit 1, which is r1, by this equation. t1 square is equal to 4 pi square by gmp r1 cube. So 4 pi square is a constant, g is the universal constant of gravitation, and mp is the mass of the planet. So this is actually total, this mass is constant. So I can write t1 square is equal to some constant k multiplied by r1 cube. And this happens for T2 also. K R2 cube. So actually for any satellite orbiting around the planet, T square is proportional to R cube. And you have learned this. It is a famous law of planetary motion. This is Kepler's law. T square, period of a satellite orbiting around a planet, if it is T, then T square is proportional to R cube. So this, we could start from this equation also, but just we have shown these steps for sake of clarity. Okay, now let us use this to further proceed with the problem. So I can write for both the orbits, planet 1 and satellite 1 and satellite 2, they are how they are connected, T1 and R1 and T2 and R2, how they are connected. I can simply write from this T1 by T2 whole square is equal to R1 by R2 whole cube. Can I write like this? From this T1 by T2 whole square to R1 by R2 whole cube. Okay, now for R1, R2 is unknown. So in our case, therefore I can write R1 by R2 whole cube is equal to Q1 by T2 whole square. What is Q1? It is 1 by 8 whole square in our case. And R1 is 10 to the power 4. So 10 to the power 4 divided by R2 whole cube is equal to 1 by 64. I can write. So R2 cube is how much? 10 to the power 4 whole cube divided by into R2 cube is 10 to the power 4 into 64. So it is basically 4 into 10 to the power 4 whole cube. I can write like this. This is so R2 is 4 times 10 to the power 4 kilometer. So R2, the radius of second satellite is 4 times 10 to the power 4 kilometer. Okay? All right. Now, what is the speed of satellite 1? V1 is the speed of satellite 1. V1 is actually R1 omega 1. Okay? So it is actually R1 into 2 pi by T1. It's 2 pi. R1 is how much? R1 is 10 to the power 4 by Q1 is how much? 1 hour. So it is 2 pi into 10 to the power 4 kilometer per hour. I can write like this. And what is V2? V2 is R2 omega 2. Because in circular orbit, you know, speed, linear speed is connected to angular speed by V equal to R omega, this relation. So it is how much? R2 into 2 pi by T2. So R2 is how much? R2 is 4 into 10 to the power 4 into 2 pi divided by T2 is 8. So it is how much? So it is pi into 10 to the power 4 kilometer per hour. All right. So we have V1 equal to 2 pi into 10 to the power 4 kilometer per hour, and V2 equal to pi 5 to 10 to the power 4 kilometer per hour. Okay. Now what is said? Now let us remove this part. Now what is said? The speed of S2 relative to S1. The speed when S2 is closest to S1, when S2 becomes closest to S1 actually. So this happens when both are in same line with the planet. So this is moving in this direction, this is moving in this direction. So S1 becomes closest to S2 when S2, S1, P are in the same line. Okay, so its velocity's direction is this direction, its velocity's direction is this direction, and it is closest. Otherwise, always their distance is more than this. So what is the distance between the planets, the satellites? In this case, when S2 is nearest to S1, its distance is actually R2 minus R1, and that is the minimum distance between the satellites. Now, what is said? What is said? So when they are nearest to each other, just observe this. When S2 is closest to S1, that means in such configuration, when all P, S1, S2 are in same line, then S1 is closest to S2. Then what is the speed of S2 related to S1? So you know, if there is a particle A and B, if particle A has a velocity vector va, and if particle B has a velocity vector vb, you have learned in mechanics, then what is the relative velocity of B with respect to A? Relative velocity of B with respect to A is what? Do you remember from your mechanics class? It is actually vector dv minus vector d. As simple as that. That means A assumes that it is at rest, and if it is at rest, then what is the effective velocity of B? It is Vb minus V. Okay, so here also same principle. What is the speed of S2 relative to S1? So when they are in the same line, the velocity of S2 with respect to S1, this is V2 and this is V1. So obviously it is V2 minus V1. So relative velocity of S2 with respect to S1 is actually V2 minus V1, and we are not bothered about vector because when P, S1, S2 are in same direction, then both are tangential. That means both velocities are parallel to each other. So vector, their difference is simply V2 minus V1. There is no angle between these two vectors. The angle between V1 vector and V2 vector is 0 degree. That means they are parallel vector. Therefore, it is V2 minus V1. And V2 we have found out is pi 10 to the power 4 minus 2 pi into 10 to the power 4. The unit is kilometer per hour. So it is minus pi into 10 to the power 4 kilometer per hour. I can give a vector sign also. So relative speed is magnitude of this quantity. Speed is a scalar. So relative speed is magnitude of v2 minus v1, which is nothing but pi into 10 to the power 4 kilometer per hour. Okay, so relative speed of S2 with respect to S1 is pi into 10 to the power 4 kilometer per hour. Okay, so that is the answer of the first part. Okay, pi into 10 to the power 4 kilometer per hour. One thing you should know that when they are moving in this direction, whose velocity is more? These particles, this satellite's velocity is more compared to this. It happens because of basic mechanics, d square is proportional to us. That means this satellite is moving faster, this satellite is moving slower. So when two trains move parallel, if one is moving faster, another is moving slower, depending upon their position, sometimes you see that the other train is moving backward. Here also it is same. And that's why the negative sign has appeared. That means S1 sees that planet or satellite is moving in the opposite direction, not in the actual direction. So it's confusing. That means what S1 observes, it is moving in opposite direction. So that's why negative sign has appeared over there. But problem has only asked for the relative speed. That means what is the magnitude of the speed. So we need not bother about sign. So it is pi into 10 to the power 4 kilometer per hour. So
negative sign is opposite direction.
Negative sign with respect to S1. Though actually with respect to independent observer like me, who is sitting outside the reference frame where they are moving.
But actually both are directly in the same direction.
Same direction, that means this anti-clockwise. But with respect to an observer sitting on S1, S2 moves in the negative direction, opposite direction. So magnitude of the relative velocity is this thing, pi to 10 to the power 4. So it is, you see, it is nothing, very simple problem. It appeared in IIT actually. So your basic concepts, it is clear. There is nothing difficult to solve this problem. Okay, now next part of the problem is little tricky, little tricky. What is that? Next part of the problem, let us see. So let me remove all these things. R2 we have calculated, R2 is R2 I have written somewhere. It is actually R2's value is 4 into 10 to the power 4. So let me write this over there. So this much I can remove from here. Okay. Now, what is the next part of the problem? The angular speed of S2 as actually observed by an astronaut in S1. What is the angular speed? It was earlier we are talking about simple speed, that means it is linear speed. Now, what is the angular speed? So, if there is an observer, a fixed observer, and if somebody is moving with a velocity v, so you know, and if this distance is r, so v is equal to r omega in case of circular motion. You know. So omega equal to v by r, where v is the linear velocity of this particle. If this particle p is moving around here, if v is the linear speed of the particle with respect to f, then that velocity divided by the distance between f and p is the angular velocity. Now, when they are nearest to each other, what is the distance between them? So, angular speed of S2 as actually observed by astronaut in S1. So, what is the distance between them? So, this distance r is actually how much? R2 minus R1. Not R2, capital R2. I should say it is capital R2 minus R1. So it is how much? R2 minus R1. It is
And then it should be the small.
3.
Capital R also.
Now, I call it smaller. So I call this distance smaller, but that is R2 minus R1. So it is 3 into 10 to the power 4 kilometer. Okay? And we have already R2 minus R1, this distance minus this distance. That is the separation between S1 and S2. And what is the relative velocity of S2 with respect to S1 that we have already calculated? That is actually relative velocity of S2 with respect to S1, relative speed rather, is we have already calculated, that is pi into 10 to the power 4 kilometer per hour. Okay, so omega is how much? Omega is this much. Omega of 2 with respect to 1. Omega to 1 means I am writing angular velocity of satellite 2 with respect to satellite 1 is actually V2 minus V1 divided by small r. Small r is the distance between them. Okay, so what is that? I have already calculated this to be pi into 10 to the power 4. Pi into 10 to the power 4 kilometer per hour. Units you should be very careful. That divided by r is how much? 3 into 10 to the power 4 kilometer. So it is how much? So this is actually radian per hour because when I am doing omega, so it is pi. Pi is actually pi radian, pi by 3 radian per hour. Radian per hour. So omega to 1 comes out to be pi by 3 radian per hour. That means pi by 3 is 60 degree. That means when they are nearest to each other, the astronaut in S1 will see that every hour it is shifted by 60 degrees. So if there is a meter or something, telescope or something like that, you will observe that when they are nearest, the angular velocity will be 60 degree per hour or pi by 3 radian per hour. Okay, so this is the flow of the problem. I hope you have understood how the problem could be solved. So this is pi by 3 radian per hour and this is pi into 10 to the power 4 kilometer per hour. Is there any doubt? If you have any doubt, give us feedback. We will further clarify. Okay. So this one problem I wanted to solve from gravitation. Now let us take a problem from mechanics. Okay. So okay. Now there is another typical problem from mechanics. Let us see. In this class, we will just try to give you some sample problems from different chapters. Okay. So, what is this problem? Let us see. If any clarification is sought during the live class, please let us know. Okay, who is there? So, a force F is minus k x I cap plus y j cap. K is a constant, acts on a particle moving in xy plane. So this is xy plane. This is xy plane. and the particle is moving in the xy plane under the action of this force. Force is dependent on x and y. That means in different xy, the magnitude or the force vector acting on the particle, they are different. Now, starting from the origin, the particle is taken along positive x-axis to a point A0. Call this point A. Okay? And then to point AA. So this point's coordinate is AA. Call this point B. Okay. The total work done by the force on the particle is how much out of these four options? So first the particle is taken along positive x-axis from point O to A, and then under the action of the same force it is taken to point B, whose coordinate is A. Then how much is the work done by the force on the particle? That we have to calculate. So you know work is actually force. If dW is the work in displacing a particle by distance ds under the action of force F, then the work is dW equal to F dot ds. You have learned from basic mechanics. Now here, what is the work done in taking the particle from origin to the point O? So I call this notation W01 is the work in taking the particle from origin to the point A. And what is that? It is actually integral x equal to 0 to A. You just try to follow this notation. F dot dx. Okay, from this notation I can write the total work. From this I can write total work is actually integral F dot dx from S1 to S2. From S1 point to S2 point, what is the work done? That is this much. So this is your basic mechanics knowledge. So here W01 is work done by the force in taking the particle from origin to the point A is x equal to 0 to A F dot dx. What is F dot dx? See, dx is a vector. I can write as I cap dx because it is the differential or elementary displacement along x-axis. So it is unit vector is I cap only. So it is how much? It is integral 0 to A x equal to minus kx dx. Is it okay? So it is as simple as it is minus k x square by 2 0 to A. It is how much? Minus k x square by 2. I can write like this. And now let us calculate what is the work. Now we have reached up to the point A. Then point A to point B. It is point A, sorry, not 1, it is point 0 to A. Here point A to B, how much is the work done? Is actually which quantity is varying over here now? X is constant because x is A. If I take the particle along AB, then x is fixed. Y is changing from 0 to y. So y equal to 0 to A. F dot, and here displacement is along y direction. So I write F dot dy. So F dot dy integral, and the limit of integration is y equal to 0 to y equal to A. I think this is very basic calculus. Class 12 students, I think you are comfortable with this. And class 11 students, actually you just get familiar with the notation. Once you learn calculus, then these things will be simple for you. So it is how much f dot dy. F is actually this component will not contribute because dy is actually how much? Dy vector is actually j cap dy. So it is 0 to a y equal to 0 to a minus ky dy. So it is how much? It is simply minus ky square by 2 0 to a. So it is again minus k square by 2. Any query has been raised by any student? No, not yet. So what is the total work? Is actually 0 to a plus a to b. So it is how much? It is just you add them. It is minus k square. Okay. So k square. This is the minus k square. This is the correct answer. This is answer C. Okay, so I hope the steps are clear. Here actually it is we are involved with only one concept, that is how much is the work. Work is f dot ds and total work is integral of that, because every moment at every point the value of the force vector is changing. Therefore I have to integrate, and this is this much. And total work in moving the particle from this point to this and from this point to this separately we have calculated and we have added them up. So it is minus k square. So C is the correct answer. Okay. All right. Then, okay, let us consider this problem. This is another interesting problem. Let us see what is that. A particle of mass m is moving in a circular path of constant radius r such that its centripetal acceleration ac is varying with time t as ac equal to a square r t square, where k is a constant. Okay, the power delivered by the particle, power delivered to the particle by the force acting on it is how much? So there's a peculiar problem. So when a particle executes a circular motion, actually we have learned that it moves with uniform speed, and for such motion we need a centripetal force acting always towards the center of the circle, and if it moves with uniform speed v, then the value of centripetal force Fc is m square by r, if r is the radius of the circle. This much you know. But here what is happening? The centripetal force is centripetal acceleration. Centripetal force is mv square by r, and centripetal acceleration expression that you know, that is v square by r. You might have read in your basic mechanics. And see, the magnitude of centripetal acceleration is v square by r, and force is mv square by r. Magnitude of centripetal force remains constant all the time, but the direction changes. That means it is acted upon, the particle is acted upon by a varying force, because force when it is at this point the force is in this direction, when it is at this point the force is in this direction, when it is at this point the force is in this direction, but the magnitude of the force is always constant. and the force vector is changing. And as a result, the particle's velocity vector is also changing, keeping the speed of the particle fixed. Velocity vector means the magnitude of the velocity of the particle remains constant, but its direction is continuously changing, being tangential to the surface. But here there is a peculiarity in this problem. This problem also appeared in a previous year IIT advanced. Okay, here centripetal acceleration is varying with time. Centripetal acceleration is varying with time. At particular time it is this much. At some other time it is always proportional to AC is actually k square or t square. So what happens? Every moment the velocity of the particle also will change. Speed, velocity is changing, not only its direction, its magnitude is also changing. That means V, magnitude of V, if I call it V, this is also changing. That you can assume. And as a result, what happens? Here, when the particle moves in circular motion, then what is the kinetic energy K of the particle? Kinetic energy is actually half m v square. And since V is constant, therefore his magnitude is constant, so kinetic energy of the particle remains same. So energy does not change when the particle moves in the circular orbit. If you consider there is no other energy, even there is no potential energy of the particle. Say it is moving in a horizontal plane, then the potential energy remains same. Kinetic energy is half mv square, which is constant. But in this problem, what is the peculiarity? Since acceleration is function of time, therefore the speed of the particle will be function of time, and as a result, every moment its kinetic energy is increasing. And that means it is the particle who is executing the circular motion, it is gaining energy as time passes. And it is gaining energy in the form of kinetic energy. Who gives this energy? The constant with its centripetal acceleration AC is varying with time. So what is the power delivered to the particle by the force acting on it? That means since the force is function of time, the force delivers energy to the particle, and as a consequence, its kinetic energy is increasing. Okay, now let us see what is its velocity. When the instantaneous centripetal acceleration is this much, so instantaneous acceleration I can write this much of a square or t square. Okay, so what is v square from this? I can write is actually k square r square t square. Okay, then what is the instantaneous kinetic energy? Let us not use this symbol k because there is a symbol k over here. I call this kinetic energy as E. Okay. So what is the kinetic energy of this particle? E is half mv square is half m k square r square t square. Is it okay? This is the kinetic energy. Now you see every moment m is fixed, k is fixed, r is the radius of the circle is fixed, but it is function of t. And every moment the kinetic energy of the particle is increasing quadratically. Okay. So it is gaining kinetic energy. So what is the rate of change of energy of the particle? And that is d dt. And this is actually d dt, the energy I am delivering to a system per unit time is called the power. Power is what? Power, you know from basic physics, is the rate of change of energy with it okay? So power P is nothing but power P delivered to the particle by the force is actually dEdt. And what is this? This m k square r square into t. T square differentiate, if you differentiate t square with respect to t, it is 2t and there is a half. So it is this much. M k square r square t. So this is the power delivered by the particle. The power delivered to the particle by the force is actually m k square r square t. So this is the answer, m k square r square t. And power delivered is also not constant. Power delivered is also changing with time. So answer is B. So it is also a peculiar problem that particle is acted upon by a centripetal force which is a function of time, and because of that this force is delivering energy every moment to the particle, and as a consequence the particle's kinetic energy is increasing and the rate of change of energy is actually the power delivered, and that is m k square r square t. Is it okay?
Yeah.
So this is a problem. See, basic simple concepts are important. Nothing more than that. Only thing you have to understand that what is the part. P is not. It is not a vector. I should not give any arrow over there. P is a scalar only. P is dEdt and this much. Okay. So see, very simple calculation, and you get, if you solve this, you get full marks for this problem. Small problem. Okay. Okay, let us consider another problem. Again, this is a very basic problem. Again, this is a IIT advanced problem. See, it is not very difficult but tricky. How it is solved? Let us see. A stone tied to a string of length L is hurled in a vertical circle with the other end of the string at the center. At a certain instant of time, the stone is at its lowest position and has a speed u. The magnitude of change of its velocity as it reaches a position where the string is horizontal is this much. See, try to understand what it is said over in this problem. So, consider a circular motion which is in the vertical plane. Plane of the board, this board, smart board, it is a vertical plane, and this is, it should look like a circle. It is not looking like a circle. Let me redraw. Okay, so this is a circular motion, and it is, the particle is executing the circular motion. The stone rather, it is stone S. It is moving in a vertical plane, and it is moved using a string. So there is a string of length L, and it is moving in a vertical plane. Okay. Then what is there? When it is at the lowest position, that means when it is at this position, say A, then its speed is u, and invariably, since it is executing a circular motion, its speed u means velocity is tangential. So direction of velocity will be in this direction. So if I consider a coordinate system, this is x, this is y, this is horizontal direction, this is vertical direction. So I can write velocity of the stone at position A as what you can write. You just try to follow the steps carefully. Little use of vectors, whatever you have learned in vectors. If you can properly, appropriately apply in such problems, then it becomes very easy. So what is the velocity of the particle when it is at the lowest position A? If I call it VA, magnitude of VA has been said to be U. So VA is actually I cap U. I cap is the unit vector along x direction, and j cap is the unit vector along y direction. So VA is I cap U. Is there any doubt? Now, what is asked in this problem? The magnitude of the change of its velocity as it reaches a position when the string is horizontal. That means at this position the string is vertical, and when the string is horizontal like this, then the stone reaches the position B. And when the stone reaches the position B, the string is horizontal and the velocity vector will be in this direction. And I do not know what is the velocity of the particle V. So V is unknown to me. It is tangential. What is the magnitude of this velocity vector? I call it V. So small v, you call it small v. Okay. Now, what is VB? VB, I can say it is V whose value is yet to be evaluated, but its direction will be along y direction. So I can write it is j cap. Okay. So these two steps are very important. VA vector is I cap u and VB vector is j cap u. Okay. Now you see this is a vertical plane, this plane. So when the particle moves from this to this, what is the total energy of the particle when it is at A? So if I take this level and if I assume the potential energy of the particle at this level as 0, then because you know potential energy is always relative. We always calculate the difference in potential energy. If I call the potential energy at this level 0, then total energy is actually half mu square, which is purely kinetic. Half mu square. And if you do not want to take potential energy as 0, then you take something, say phi 1. So it is, in that case, it is half mu square plus phi 1. Phi 1 is the potential energy of the particle at position A. I call it A, phi A. So total energy of the particle, mechanical energy of the particle at position A is actually half mu square plus phi A. Now, when the particle is at position B, I have assumed that the speed of the particle as v, which is tangential and vertical, so it is half kinetic energy is half mv square. And what is the potential energy of the particle at position B? So phi b, I can always write phi a plus mgl. Because mgh, you know the potential energy. So this distance is L, nothing but the radius of the circle, which is length of the string, and therefore phi b equal to phi a plus mgl. If I assume phi a to be 0, then K is half mu square and Pb is half mv square plus mgl. But if I take this as phi a, potential energy at this level, then it is phi a plus mgl. Now total energy is conserved, so I can write half mu square equal to, because both are equal, pa equal to tb. So phi a they cancel from both sides, so it is half mv square plus mg l. Is it okay? Now from that, u is known but v is not known for us. So v square I can write is equal to u square minus 2gl. I can write like this. Okay, so let us keep this relation ready for our further calculation. Now, what is the question? The magnitude of the change of its velocity as it reaches a position where the spring is horizontal. So, magnitude of its change, magnitude of the change of its velocity. So, change of its velocity of particle is how much? Change of velocity is how much? Vector vb minus vector va. Okay, so vector vb minus vector va is how much? Is actually vb is actually I have written j vb, j cap v minus I cap u. So you are changing velocity, it is vector gb minus va has come out to be minus I cap u plus j cap v. Up to this it is okay. Now what is asked? The magnitude of change of its velocity as it reaches position where the spring is horizontal. So I have to take the magnitude of this vector. So what is the magnitude of this vector? Magnitude of vb vector minus va vector. So if you have a vector f which is I cap alpha plus j cap beta, then what is the magnitude of this vector f? Is how much? It is square root of alpha square plus beta square. Simple. So here also it is how much? Minus u square root of minus u whole square plus v square. So it is how much? U square plus v square, but v square is u square minus 2gl. So it is 2u square minus 2gl. Okay, so it is basically 2u square minus gl. So finally I could write that if I just remove this thing, vector vb minus vector va, changing velocity, its magnitude is actually square root of 2 u square minus gl. So this is the correct answer, 2 u square minus gl. So answer is D. Okay. See here, thing is that up to this it is okay. That means equivalent TA equal to TE, and from that you can find that v square equal to u square minus j. But T is the magnitude of change of its velocity. So it is a change of magnitude of change of velocity. So you should not make it v minus u sort of thing. There is a common mistake. This is the velocity at v and this is the velocity at u. So difference is v minus u. No, because this is a vector and this is also a vector. And Unless the vectors are in the same direction, you cannot do algebraic sum or difference. So this concept, whether you know or not, that has been tested in this problem. So at point B, velocity is Vb equal to j cap v, and point A, the velocity is I cap u, and v and u are related by this equation. So differentiate velocity is actually, I have calculated, it is jv minus I, j cap v minus I cap. And then you calculate, see, j cap v minus I cap u, it is difference of two perpendicular vectors. So their magnitude is this much, square root of v square plus u square. And from that you have to calculate. So that's why this problem is tricky, this part of the problem. So if you know how to use vectors, vectors is a very important concept. And when you are dealing with vector type quantities like velocity, acceleration, force, then you should be very careful when in some problems if it is asked that you calculate the difference or addition, subtraction. So when you are adding or subtracting vectors, you should be taking care of the directions, and it is always convenient if you express the vectors in terms of unit vectors I, j, k, and then manipulation becomes easier. And that part has been tested, and this is the problem. Okay, I hope this is clear. Okay. Okay. Now, how much time is left for some problem from mechanics? Okay, now let us take a problem from some other chapter. Say, for example, electricity, one problem, class 12 students, for them, just let us take a representative problem from RC circuits. Okay, this is also IIT problem. Okay, so in today's class, just we are discussing the problem solving techniques. How problems can be tackled. Problems are not very difficult, but your concepts are very important in handling this problem, such problems. This problem is also such a problem where basic concepts are involved. Electricity, magnetism, these are very important topics, as you know. So, what is this problem? Let us see. And if you need any further clarification, don't hesitate, write to us. We'll try to give further clarification. So, what is the problem? See, in the circuit shown in figure, the switch S is connected to position P, this position, for a long time. So when the switch S is connected to P, then what is the circuit looks like? What is the look of the circuit? It is like this. So it is a 1 ohm resistance, it is a 2 ohm resistance, it is a 1 microfarad capacitance, it is a 2-volt battery, it is a 1-volt battery. And you know this is the battery's positive negative poles. Okay. Now it is kept in position P, so there is no role of Q in this. So I just remove Q from this line from the diagram. Now when the switch is kept in position P, then the circuit looks like this, and it is continued for a long time. In the circuit, the switch S is connected to position P for a long time. That means long time has a significance, this phrase. That means the circuit has attained a steady state. Because you know when there is a capacitor in a circuit, then capacitor takes some time for its charging. And finally, it acquires a steady state and it holds a fixed amount of charge. Depending upon the potential difference between the plates of the capacitor. Now, what is the potential difference between the plates of the capacitor? That you have to find, and once you know the potential difference between the plates of the capacitor, then you know the charge acquired by the capacitor is nothing but Q equal to CV, where C is the capacitance of the capacitor and D is the potential difference between the plates of the capacitor. Now, in this situation, what is the potential difference between these 2 points in the steady state that you have to find out? Now, such type of problems, I advise you mark points. Call this point 1, call this point 2, call this point 3, and call this point 4. These are the nodes in the circuit. And 4 means this plate of the capacitor is connected to point 4. This plate of the battery is connected to point 4. And this plate of the battery, that is negative pole of the battery, is connected to the point 4. And all these points are same point topologically from electrical consideration point of view. Okay. Now, in the steady state, capacitor does not conduct any current because the voltage is a DC voltage. Had there been AC voltage across a capacitor, the capacitor conducts current. But if there is a DC voltage, the field between the plates of the capacitor is fixed, constant, time invariant, and therefore there will be no current flow. So in this direction, there will be no current. So as far as electrical current flow is concerned, whether the capacitor is there or not does not matter. So as far as current flow is concerned, the circuit reduces to this. So this is the basic concept. Okay, so this is a 1 volt battery, this is a 2 volt battery, this is 2 ohm resistance, this is 1 ohm resistance. Then what is the current flow in this set? I have just removed the capacitor from this because it has no role. So this is 0.1, this is 0.2, this is 0.3, and this is 0.4. Then what is the current flow in this circuit? Current, this is higher size capacitor battery, this is lower battery. This is a 2 volt battery, this is 1 volt battery. So it drives current in this direction, this drives current in clockwise direction, and this drives current in anti-clockwise direction. But since it is a 2 volt battery, the net current will be anti-clockwise. There will be anti-clockwise current flow in the circuit. So what is the current flow? So I, if it is the current flow, I into 2. This is voltage drop across 2 ohm resistance plus 1 into I, voltage drop across 1 ohm battery equal to net voltage, which is 2 minus 1. So 3I is 1. So I is 1 by 3 ampere. Unit is ampere. When I 1 by 3 ampere current is flowing in this, then what is the potential drop between 2 ohm resistance? So I can write V1 minus V2 is how much? Ohm's law, you apply Ohm's law over there, is I into 2 into I. So it is 2/3. This is one equation. Then what is the potential drop across 1 ohm resistance? It is V2 minus V3. Simple Ohm's law. V2 minus V3 is I into 1. So it is 1/3. So this is another equation. Okay. So what is V3 minus V2? V3 minus V2 is how much? V3 minus V2 is how much? It is 1 volt only, because between point 3 and 4, V3 minus V4, sorry, it is not V3, V3 minus V4, the potential difference is 1 volt only. So this is another equation. So I am interested to know about V2 minus V4. Okay. And what is V1 minus V4? V1 minus V4 is 2 volt. This is another equation. So V1 minus V2 is 2/3. V2 minus V3 is 1/3. V3 minus V4 is 1, and V1 minus V4 is 2. 4 equations. Let us this one. This is 1. This is 1. This is 2. This is 3, and this is 4. Now I am interested to find V2 minus V4. How can I find that? V2 minus V4. V2 minus V4 I can find out
In between 1 and 2.
between 1 and 2. No, it is V2 minus V3. This is V2. This is V2 minus V3. This is V2 minus V3. No? This is V2 minus V3. This is 1/3. It is V1 minus V2. It is 2i, 2/3. V1 minus V4. It is 2, and V3 minus V4, it is 1. So what is happening? V2 minus V4 is how much? V2 minus V4, if I want to calculate, so I just add this. This is V2 minus V3, V3 minus V1, V4. V2 minus V3 is how much?
And can we just put 2 and 3 together?
V2 minus V3 is this one, 1, and V3 minus V4 is 3. V3 minus V4 is 4. So 1 plus 4 if I make. 1 plus 4. So V2 minus V3 is 1/3, and V3 minus V4 is 1. So if you add them, what happens? If you add them, then what happens? Just they cancel, so I get V2 minus V4 is how much? 1 plus 1/3, 4/3. Is it okay? Now V2 minus V4 is 4/3 means between these 2 points, potential difference is this one volt, 4/3 volt. That means between the plates of the capacitor, the potential difference is 4/3 volt. Because when there is a current flow, there is no current in this part. So current is actually flowing like this. So potential difference between V2 and V4 is this much. So what is the Q? Q in this case is said to be Q1, is it not? So Q1 is actually C V2 minus V4. C V2 minus V4. Okay, so what is happening? Just let me remove this part. So what is the expression for Q1? Just try to follow. Q1 is C is how much? C is 1 microfarad. So it is 1 microfarad multiplied by V2 minus V4 is 4/3 volt. It is 4/3 volt. So it is 4/3 microcoulomb. So it is 4/3 microcoulomb is 1.33 microcoulomb. So Q1, value of Q1 is 1.33 microcoulomb. So when the switch is kept in position P for a long time, this capacitor, it acquires a charge Q1 equal to 1.33 microcoulomb. I think this part is clear. Okay, so this answer we have already obtained. Now, what happens? Next part is after a long time, the charge on the capacitor is Q. Now, what happens? Then S is switched to position Q. Now, let us remove all these things. Okay, so we have calculated Q1. All these things let us remove. Now, what is the circuit? The switch is moved to position Q. As soon as the switch is moved to position Q, the first battery, that means left battery, 1 volt battery, is bypassed. It is not coming into picture. Is it okay? Okay. Okay. Okay, let us, this part is over, first part, second part, let us do it once again. Second part of the problem. Second part, what is that? First part we have already obtained, Q1 is 1.33 microcoulomb. Alright. Now, second part, the switch is switched to, S is switched to position Q. So, as soon as it is switched, moved to position Q, the circuit looks like what? This is 1 ohm, this is 2 ohm, this is 2 volt, and it is like this. There is no 1 volt battery, it is bypassed, and capacitor is in between. Same approach. Now, what I do, I call this point 1. Always in electricity problem where we have to calculate the potentials, you give names of the nodes. You call this point 2, you call this point 3, and these 3 are all same. This is also 3 because there is no resistance in between. So these 2 points are short circuited. Therefore, as far as electrical potential is concerned, this point, this point, this point are same. So I call it 3. Now in this position, again the current flows in this way, anti-clockwise direction, and there is no current flow through the capacitor because in the steady state, when there is a DC voltage applied across capacitor, capacitor does not conduct any current. This is the fundamental thing. So as far as current distribution is concerned, there is no current in the branch 2 to 3. So I can, if I assume I current is flowing in the circuit, then 2 into I plus 1 into I is equal to 2. Ohm's law, simple Ohm's law. So it is 3I equal to 2, so I equal to 2/3 ampere. Okay, now again you apply previous one, just like previous one, Ohm's law in each segment. So V1 minus V2 is how much? 2 into 2/3. So it is 4/3 volt. 4/3 volt. 4 into 1. Then V2 minus V3 is how much? 1 into 2/3. So it is 2/3 volt. Okay. Now I am interested to find the potential difference between the plates of the capacitor, which is nothing but V2 minus V3. And V2 minus V3 is actually we have already obtained. V2 minus V3 is this much, 2/3 volt. So V2 minus V3 is 2/3 volt. So if the potential difference between the plates of the capacitor is 2/3 volt, then what is the charge acquired by the capacitor? Is nothing but Q equal to capacitance multiplied by potential difference across the board plates of the capacitor. So it is C is 1 microfarad. So Q2 becomes 1 microfarad multiplied by 2/3 volt. So what is this? It is 2/3 microcoulomb. 2/3 microcoulomb is 2/3 is actually 0.66666 continues like this. So it is approximately 0.67. So it is Q2 is 0.67 microcoulomb. Coulomb. So Q2 is 0.67 microcoulomb and earlier we produced Q1 is 1.33 microcoulomb. So see, this is also IIT problem actually, IIT advanced problem. So they are testing whether you can compute the simple potential difference at different nodes and whether you can apply the concept how much charge is acquired by a capacitor when there is a steady voltage between the plates of the capacitor is DC voltage whose magnitude is say 230 volt. Once you know that, this is a basic fundamental concept, and you have to do some little analysis to calculate the potential difference between the plates of the capacitor. If you can do that, you can crack the problem. As simple as that. So if you practice similar type of problems, it is not very difficult to solve the problems given. So this is what I wanted to cover. Some few problems, interesting problems I picked up for today's class. So with this I conclude physics class. There will be further classes on maths and chemistry.
Next math class is 11:30, correct?
Okay.
11:30.
11:30. So 9:30 to 11 was the class for physics class. So next class, next maths class. Next math class is at 11:30. Please join us and give your comments. And if you have any observation, any clarification required, please let us know. So thank you very much for your listening. Thank you once again. Good job.